Okay, so in this first video, we're going to look at some of the topics from Chapter 7 that deals with classes and objects. Alright, so if you've installed Visual Studio already, we can go ahead and launch that. I have the icon here. This is for Visual Studio Express 2012. And then to create a new project, we're going to go to File, New Project. And then you may have a whole bunch of different templates and different things installed. What we want to go to Visual C++, and you're going to click on Win32, and then you're going to click on Win32 Console Application. And then you're going to name the project. In this case, we're going to do a video lab. And we're going to do it on a rectangle class. So you click OK. And then you're going to get this dialog box here. Go ahead and go to Application Settings. And then click on Empty Project. And then go ahead and hit Finish. Okay. Now you may see some panes here, or you may not. But in case you don't see any, like the way it's here, the only pane we really want is going to be, we're going to go click on View, and then we're going to go to Solution Explorer. And this kind of shows us our structure for our project. Now our project doesn't have any source files in it because we created an empty project. So we can go ahead and add that. So I'm going to click on here, right click, go to Add. We're going to add a new item. And we're going to add a C++ file, .cpp, and you can leave the default name. So click on Add. Okay. And then we can go ahead and zoom in. And then here we can start coding. If you want to just test your IDE real quick, we can set up the main parts here, the IOStream header. Using namespace std int main, and then we'll do return 0. Okay, so this is a complete program, so we can run this. We can go to debug and then start without debugging, or you can do Control F5. And then that shows us our program here. So it's running. If you want to see something, an output of some sort, we can just do cout hello world. Alright. And then Control F5, and that'll compile our program. And then we see the text there. Okay. Now what we're going to do here for this program, I'm going to reduce the size of my Solution Explorer a bit. What we're going to do here is we're going to do what's called a class. So we're going to do a class definition. And a class, you can think of it as a programming construct or a blueprint that's used to define your own data types. Right? We have regular data types like ints and strings and doubles, but here we're going to create our own data type. And the type of data we're going to create is for a rectangle. Okay. Usually classes consist of member or members. We can either have member variables or member functions. Right? So a class has attributes. You can think of those as nouns. For a rectangle, for instance, a rectangle has a length, it has a width, and then it may have some sort of functions or some sort of operations. You can think of those as nouns or actions. Some of those actions or methods could be to calculate the area, calculate the perimeter. All right, so we'll look at that. You can think of a class as a blueprint. A blueprint, it's kind of, what do you use a blueprint for? A blueprint is used normally to plan out a house, right? So you have the blueprint, you have the plans, how it's going to build, how are you going to build it, where the bathroom goes. That one blueprint can be used to build multiple houses, right? You can't live inside the blueprint, but you can live inside the house that is generated from the blueprint. So that's a way of, you have to think of a class. A class is just setting up the instructions or the definition of how to build the rectangle or how to build the house, but you're not actually building the house. The house doesn't actually exist yet. The rectangle doesn't exist yet, right? We have to first define it. Once it's defined, then we can create an object of that class, and then that object can reside in the computer's memory. Okay, so to define a class, we have the keyword class, and then the name of the class. So in this case, it's going to be called rectangle. And then similar to a function, it's got an opening brace and a closing brace, but it also ends with a semicolon. So that's a little bit different, unlike the function. The function usually doesn't have a semicolon that goes here, but for the class, it does. So this defines the end of the class. Right, and your definition for your class is going to go in between these two brackets here. Now, we're talking about the members of the rectangle. The members can be organized into two levels of accessibility. We have our private members and we have our public members. The private members can only be accessed within the class itself. They can't be accessed outside of the class. The public members, however, can be accessed outside of the class, and we can access those in the main or in a different class or anywhere else. All right, so usually our classes are going to have both private and public members. Right, so anything that goes below private, no one will have direct access to it except the class and the functions within the class itself. All right, so we'll see it in action in a little bit. So our rectangle consists of two things. It's a length and it has a width. All right. Now this length and this width, remember this is just the definition of the class. These variables don't actually exist yet until we create an instance of our rectangle class. So you can't really assign values to it or anything. You just have to put there what two things make up the rectangle. Like let's say we made a class called student, then the student would consist of a name, maybe a first name, a last name, an A number, a GPA, right? A student wouldn't have a length and width. That wouldn't make sense. Maybe a weight, maybe a height, but not length and width. But for a rectangle, it is appropriate. But a rectangle doesn't have a weight, so then that wouldn't work there either. Okay, so these private members, we want to protect them from being accessed directly, because we don't want somebody putting in information into the length and width that doesn't make any sense. For instance, if I try to create a rectangle with -5 as the length, that wouldn't make any sense, right? There's no such thing as a rectangle with a negative length, right? These here are called member variables. Right? And normally the member variables are private. There's some cases where they may be public, but for the most part they are private. Okay, so as far as our public members, the first main public member that we need is going to be our constructor. Our constructor is a special function. It's a special function used to create an object of the class. So if I want to create a rectangle, I'm going to have to use my constructor to create that rectangle. The constructor also initializes the member variables. Okay. Now, to write a constructor, the constructor has to have the same name as the class. So our class is called rectangle. It has a set of open parentheses, and then the definition for this rectangle constructor. And remember, it's supposed to initialize the member variables. These are the member variables. So if I want to create a rectangle to start off with, the most basic rectangle is going to be a length of 1 and a width of 1. Right? So now we have a rectangle that's 1 by 1. And this constructor will generate that for us. But normally we want to set our own length and our own width. We don't want to use the default values, right? We can think of this without the parameters here, without any sort of arguments. In the parentheses, we can think of this as a default constructor, right? And default, well, we'd start with 1 and 1, but we don't want just to have a length of 1 or a width of 1. So we can create what are called, these are other members. These are going to be called set functions. And we can use these functions to set our length and width, or to set our first name, to set our last name, but this was a student. Right? So set function. Set functions are also called mutators. And the set functions are used to provide data validation for our members. Right. Remember, we're talking about a length that is negative, right? We don't want a negative length, right? So if somebody uses a set function, tries to pass in a -5, we need to some way to fix that. So our set functions will do that for us. Normally our set functions are, the return type is void. Notice here the constructor does not have a return type. Right? So keep that in mind. That's the other special thing about the constructor. It has no return type, and it must have the same name as the class. Okay, so void here for our set function, and we're going to call this set length. And our set length is going to be a function that takes an argument. It's going to take an argument of an integer, since our length is also integer. And we'll use an L for the parameter, for the formal parameter. Right, remember this is an L, not a 1. Right. And then our set function, we can do something simple like this, where length equals L. Right? We could do this, and it would work. So let's say the user passes in a 3. That 3 will be assigned to our member variables called length. Right? So that's up here. This is okay. But what if the person tries to pass in a -3? Then it's no longer okay. All right, so we can provide simple validation here. So instead of doing that, we could do if L is greater than 1. If it is, then we will use L to initialize our length. Okay. Now, if this condition is not true, meaning that they gave me a 0, they gave me a length of -10, right? These values do not make any sense. So then we're going to have to do an else and assign the length correctly. So we'll just make it default to 1. Right? So we'll put a 1 in length's place, since they gave me a value that did not work for us. Right? This is the idea of the mutator, or of the set function. But we also need a set function for every member that we have, every member variable. So we've created one for the length. Now we need to create one for the width. So then we'll do that here. So that's going to be void set width. And then the parameter is going to be int w. And then here we'll also provide validation for the width. So if w, the value, the input to this function, if the input is greater than 1, then we'll go ahead and use that value as our width. So width equals w. Else, we'll make width 1. All right. Now, once we've set the width and length, then the other type of function that you'll find in a class is going to be our get functions. Our get functions are also known as accessors, and they're used to return the values stored in the member variables. So we have to set length and set width, and we're going to have a get width and get length. So the return type for get functions is usually going to be the same return type as the member variable itself. So in this case, let's say the length is an integer, so then we're going to return an int. The output of this get function is going to be int. And we can call it get length. And it normally doesn't take any arguments, right? Because we already know what the length is. We don't need any sort of input for our function. We don't need to define any formal parameters. And we're simply just going to return the length. Okay. And then the same thing for get width, and then we'll return the width. Okay. Now we look at these functions here, and they simply return some value. But what's the point of using them? Well, remember that all the functions here, everything that's defined after public, we can use that anywhere that we want, in any function, in a different class. However, the private members cannot be accessed outside of this definition. So we need a way to retrieve the information publicly. Right? So then that's why we define the get length and get width. Okay. Now, our objects or our classes are not simply length and width. They're not just nouns. We also have verbs, and we also have actions or methods that the function can or the class can perform on itself, right? That way it's more useful. So we call these member functions. Member functions. In some textbooks, they're called methods. And in other books, they're called operations, right? So some of the operations that can be performed using a rectangle class could be something as simple as the area of the rectangle. So let's say I have int calc area. Right, so we have this function here. Now we don't need any input for our function. We don't need any parameters because we already have access to, since this is within the rectangle class, we have access to the length and width. So we can just simply return length times width. All right, so let's say I pass in a length of 5 and a width of 5, then my area is 25. Right, and that 25 will be the output of our function. Okay. So at this point, we have enough to test out our class. Right. So now that we have our class definition here at the top, later on, we're going to learn how to separate our class definitions from our files, so that way we don't have everything all in one place, right? Because as we start adding more classes and we start making it more complicated, then our source code is going to get very long. So later on we can create header files and we can put all that information there, so that way we can simplify our source code, but we'll have multiple files. That's the only difference. So here we have our hello world statement in the main. We don't need that, right? And just like the way you define a variable, a normal variable of a data type that's already built in, like int, we have int number, and then we can assign some value to that if we wanted. Number equals 9 or whatever. Right. So we can declare a variable of a certain data type, and this data type int, of course, is built in for us. Now, when we define or declare a variable of our class, the syntax is very similar. But instead of int, we want to make a rectangle. So we'll type rectangle here. And if it's a class, you'll notice that in Visual Studio it'll turn green. And we can call our rectangle anything we want, right? So just like the way we can call this int num, we can call it int number, I can call it int num, I can call it n, I can call it x. Same thing with our rectangle variable. So our rectangle variable, I'm going to call it object, right? Now this object, what we're doing here is, let me write this down for you. Here we are creating an instance of the class, right? Using the constructor, right? So at this point, I want to display the area. If we use this constructor to create an object of our rectangle class, our constructor has a length of 1 and it has a width of 1. So then our area is going to be 1 as well. and we can verify that. So I'm going to do cout. I'm going to do a string literal. Let's say something like area. And this object, if I do object and I do the dot is called the member access operator. So if I do dot, then you'll see all the different operations and all the different attributes that this class has. We have a operation called calculate area. We have another operation called get length, get width, set length. You know what? Let's test this out. So we'll do our get length. And I'm going to put here length instead. Here I want to see the width. And then we're going to do object dot, and then we're going to get the width. Okay. And then finally I want to see the area. No, calc area. All right. So when we run this, we're going to see initially, we're going to see the length, which is 1, the width, that's 1, and then we'll see the area, which is also 1. All right. And remember the little dot here, very important. The little dot is called the member access operator. Okay. So let's go ahead and run this. Control F5. All right, and then we see the length is 1, the width is 1, and the area is 1. Okay. So it seems to be working. But let's say we want to set this value instead. We can create 2 local variables. Local variables. Local variables for input from user. Right? So let's say I have int length and width. Now this length and width are temporary variables. They're part of the main. They have nothing to do with what's here in the class. They're just a way for us to get input from the user. All right, so let's say I do cout and I prompt the user to enter a length. And then we do cin length. Okay. And then I do cout enter a width. And then cin width. Okay. We've entered the length and width into these temporary variables. And what we're going to do is we also have our object here. So now I'm going to use my member access operator. And I'm going to set the length based on whatever input the user gave me. So let me send that in as an actual parameter. And then the same thing here. Set width. Okay. So here we're getting input from the user. Here we're setting the length and width for the object. And then here we're doing the output or the display. All right, so let's run this. All right, so enter the length. So let's say I give a 5. and I give a width of 6. So then our area should end up being 30. Right? So we have the length, the width again, area 30. Let's try it again. This time I'm going to put -7 and -8. Right? So what do you think the area is going to end up being? It's all ones, right? So then that's where the set function came in. It validated the data. It noticed that the negative is not right. So then it reduced it to 1 instead. We could do it that way. We could also use, I believe, CMath, another thing I just kind of thought of right now. CMath, and maybe we can get rid of the negative. So instead of doing 1, I think we can do ABS for absolute value, and then we pass in the length. And then ABS, we pass in the width. Right? Now then I guess our if statement may not be valid anymore because now we're using the absolute value, which is going to remove the negative. But it's just a different option for you, just so you can see something different. Right. So then we kept the same values, and then we got the absolute value instead. So that way we don't end up with a length and width that are negative. Our area still would have been positive anyway, because negative times negative is positive. Okay, we can do other things though, right? We can add to this. So what other operations exist for rectangles? Well, here under our member functions, we can expand on this, right? This is the whole point. We want to reuse the code, which is the other benefit of classes. So I can create more objects, and each one of them can have their own length, their own width, their own area, their own perimeter, their own diagonal, their own whatever, right? We can also create an array of objects of a particular class. So then let's say the next thing we want to do is calc perimeter. Calc perimeter. And again, we don't need any arguments because the length and width have already been set. And then we can return the function for this is going to be 2 times length plus width. Okay. And then we can also calculate the diagonal, which would be the distance between one corner of the rectangle to the other corner. And for that, we're probably going to want to use a double return type. And then we'll calc diagonal. And then the formula for that is going to be the square root of the length squared plus the width squared. That would be return square root pow length to the second power plus pow width to the second power. Okay. And then here we can add to this. So we can do cout perimeter. An object calc. Now we have these calculation functions that show up in IntelliSense, and we can reuse them over and over and over. Same thing for the diagonal. Calc diagonal. Okay. So let's go ahead and run this. Alright, so here I'm going to just put in 5 and 5. Alright, so then we have an area of 25, a perimeter of 20, and a diagonal of 7.07. I believe that's correct. Okay. Now the last thing I wanted to show you was we can have multiple constructors. Right? We don't have to have just one constructor. Right? This is the default constructor because it doesn't have any parameters. But we can also have what's called an overloaded constructor. Overloaded. If you remember for programming 1, overloaded functions are functions that have the same name but different signatures or different arguments or different parameters. Right. So our overloaded constructor, we're going to have one here called rectangle. It's going to has to have the same name, but in the parentheses, the input for this constructor is going to have to be different than the first one. So in this case, we're going to have int length, L, and int width. So here you would use this constructor if you already know the length and the width. Now, if the user for some reason supplies input for this constructor that is invalid, then we want to make sure that the data is good. So rather than doing length equals L, we don't want to do that, because here they might put a -5, and that -5 will go into length, and then that'll mess up everything. So instead, we can use our set functions to validate the input for this constructor. So then we will do set length L, and we will do set width W. So then we can validate the data that is the information that is coming in to these functions here, using our if statement, using our absolute value, using whatever we want, right? But the point is, it's got to go through the set function, the mutator. The mutator you can think of as a middleman, right? The middleman makes sure that it's okay. If it's good, then go ahead and set the member variables using that information. Otherwise, we need to make some sort of adjustment, either removing the negative or setting it to 1. Okay. So here in our main, we're going to create a new object using the overloaded constructor. Now, we can either ask the user like we did here for input, or we can simply just supply literal values. Right. So we're going to create an object of the same data type, of the rectangle type. And then we're going to call it object2. And then we're going to open the parentheses. And we have several constructors that we can choose from. But here we have our second choice, which is the rectangle constructor that takes 2 arguments. Right? And it even has the name here, overloaded constructors. So then here I'm going to put in an 8. And then here I'll put in I'll put in a 10. All right, so here we have a object 2 using the same class. We're reusing the same code, but this time the length and the width is going to be 8 and 10. And then we can do kind of the same thing that we did here. We can copy this. Ideally, we would want a function that could do all this, so that won't have to be copying and pasting. But we'll go over in another video how to pass objects to functions, right? So, and then here instead of object, right here, so it's 2, 2, 2, 2, and 2. Okay. Yeah, we can do something like this to kind of separate our outputs. Okay. So then we go ahead and compile this. So here's for the first rectangle, it wants input. So we'll do 7 and 2. So then the area is 14. And then here's our second rectangle using our overloaded constructor. And then we have an area of 80, perimeter of 36. Is that right? So that's 18 times 2, yeah, 36. And then this is the diagonal. Okay. Okay, so in this video, what we went over was classes. We went over what are member variables. A lot of information here. But I'm hoping that all this information will help you as you start going through Zybooks, as you start going through the chapters. And since you've already done it here, it'll make a lot more sense as you start reading through it, right? Because then now you know what it's talking about. We went over member variables, we have member functions, we have constructors, we have the default constructor, we have overloaded constructors, we have mutators, set functions, we have operations, usually the things that the class does, and then that class we instantiate the class and we create objects based on that blueprint, based on this specification that we have up here. And then we looked at the member access operator, the little dot. Okay. Now, the last thing I'll go over in this video, for those that haven't taken a class with me before or have not used Visual Studio, we'll go over real quick on how to upload your assignment. Okay, so to submit your assignment on Blackboard, what you can do is go here under the name of the project, and then right click and then open folder in File Explorer. And then this source file here inside your project folder, this you're going to want to click on it, right click, send to compressed zip folder. And then this zip file is the one that you're going to want to upload to Blackboard. If you make any changes to it, then make sure you rezip it and then upload that one. So that way you upload the latest one. And then the submission link will be there where you clicked on the video link, and then that way you can submit that to me. If there's an issue with your file, I'll email you and let you know. Okay, so I hope this video helped out. If you have any questions, please email me anytime, and I'll be happy to help you out. All right. So then I'll see you in the next video. Thank you very much.